want to see how to plot your graphs after performing any experiment in physics practical. Now, for us to do that, we have a typical example of graph sheet and we have a table. This is one of the tables we are to look into. As we plot this graph for these readings we got in this table, we will see a lot to learn on that. But before then, let's see some rules, some important points we have to take note before we plot our graph. First thing in your graph is write your date of the experiment. Very important. Write the date, then write the title of the graph. Here I'm plotting a graph of sine I, then I'll put the units by the side against sine R, I'll put the unit by the side. If it has no unit, don't put anything. Like this one doesn't have any unit, so you don't put it. Now, next thing you do is label your axis. And you are labeling your axis based on where you want to start your plotting. So before you label your axis, you need to know where to start your plotting from. Label it like I personally, I will start from the end and from the end. So I'm labeling it. Labeling it implies that I will write what I have here, sine I, no unit, against sine R, no unit. Okay, now after labeling it, another important thing to do is choose the appropriate scale. Choosing appropriate scale simply means choose number that you are to put here in a uniform way and number you are to put here in a uniform way such that it will accommodate these points easily and such that it will cover at least 2/3 of this graph. Yes. Now, for you to choose it, there are some logics you are to take note of. One of the logic is that you need to ask yourself, did they ask plot a graph of this against this from the origin? That is starting both axes from the what? Origin. Did they specify you have to start it from the origin? If they specify you have to start from the origin, the implication is that I will start it 0,0 before I assign. Then I can assign that uniform number. If I'm choosing 2, I'll put 2, 4, 6, 8, and so on. If I'm choosing 1, I'll put 1, 2, 3, and so on. Then this means I am starting from the origin. Now, another point you have to note is that there are some cases that they will say start both sides from the origin. And you will notice that if you start both sides from the origin, there will be empty space at a part of a graph. Look at what I mean. Like in this table now, this is 0.5, 0.34. That is, the least number is 0.5 and the high is 0.94. Let's say they specify. Here they did not specify. But let's assume that they specify plot a graph of this against this, starting both axes from the origin. That means what I will do is, if I start 0,0 here will be, assuming I now put 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and so on. Do you notice that the plotting will be starting from 0.5 and go up? Here will be vacant. Here will be a wasted space. Are you getting it? Empty space, a waste space. So you now see that it is not a good graph. And that means obeying from the origin, we will not put it 0,0 because if you put it 0,0, it will not balance well. Now, what you have to do is, because you have realized that Writing 0, that is starting from 0, will not make a good graph because there will be an empty space, a big space vacant. Now what you will do is you just put zigzag line here. This symbol simply means, symbol you put here and here simply mean that you observe starting from the origin, but you didn't make it to be what? Visible. Now because you have done this, what you now do is that you pick a point you want to start. Maybe I want to start from 0.3. For instance, I will now know that 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and so on. That means that 0.3 is where I start, but this zigzags is sending a message that you observe starting from the origin. Now when you are plotting from 5 here and go up, at least these spaces are not too much. You can as well come and start from 0.4, 0.5, 0.6, and so on. That means you starting from 0.4 means it will only make a small space not to be used, and it will balance well in the up. 0.4, it means you have noted where you are to start from. Now we want to discuss the first case. That case is if they say plot a graph of sine I against sine R, starting both sides from the origin. If I start both sides from the origin by writing 0, 0, that is the meaning of origin. 0.1, 0.2, 0.3, 0.4, 0.5. You see where 0.5 will start? Here will be empty space, and that is a poor scale, poor graph. Because of that, I will tell them that me starting 0, 0 by writing 0, 0 will make here to be empty space. And how do I send that message to them? I will put zigzag. This symbol I put here and here is sending a message that please, I observe the rule that I'm to start from 0, 0, but I didn't write it to be visible. It means that 0, 0 is applied. The rule of 0, 0 is applied. But I decided to start from 0.4, which is the closest number to this, such that when I use 0.4, it could make small space to be empty instead of starting 0, 0, and I will leave a big space in the graph. I'll start 0.4. Now here will be 0. Here will be a number. I want to know the number I'm to put here. Then to get the number I will put here, what I will do is, since I'm starting 0.4, I will say 0.94. 0.94 minus 0.4. That will be giving me 0.54. Then how many space am I to plot? 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8. We press 0.54 divided by 8. That will give me 0.0675. This digit you see here can be approximated to be 0.1. Then it means that I will be giving an interval of 0.1 while plotting here. I will say 0.4 plus 0.1, 0.5, 0.6 plus 0.7, 0.8, 0.9, 1.0. I have labeled. You can see it covered almost the full graph. Now I'll come to the horizontal axis. I want to see how to choose appropriate scale there. I have put this symbol here, meaning that I observe the rule of starting from the origin. What I'm to do now, I will pick a number that is close to 0.3, and such that when I pick it and I start plotting, it can cover at least 2/3 of this horizontal scale. I will now say Let me pick from 0.1. Now I pick 0.1. The highest is 0.63. I will now say why I pick 0.1 is 0.1, 0.34. That is 0.1 is close to 0.34. I can pick 0.2. But the implication is that if I pick 0.2, ordinarily, if I say 0.2, 0.3, 0.4, 0.5, 0.6, I will see a bigger space left. I will say no. Let me pick 0.1 in case to see that this is well balanced. What I will now do is 0.63 minus 0.1. 0.63 minus 0.1. That will be giving me 0.53. I will say how many space? 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 9. 0.53 divided by 9. That will be giving me 0.058, approximately 0.1 to 1 decimal place. So that means I am to use the interval of 0.1 to represent my horizon. Here will be 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. That means I've choose my scale. That is when they say starting both sides from the origin, and you realize that writing 0.0 will make it possible to have a big empty space. Then you observe this protocol. Then let's see another rule. What if they didn't say starting both sides from the origin? What if they didn't say starting both sides from the origin? How can you sort it out? See what I will do. Because they did not tell me starting both sides from the origin, I can come here and put my number I want to start for vertical. Come here, put the number I want to start from for horizontal. Now for vertical, I want to start from what? Start the vertical with 0.4. Please, not 4. Starting it from the beginning, 0.4. Because they didn't specify. I'm checking another case where they say plot a graph of this against it without specifying. I will say 0.1 against 0.4. This is for x, this is for y, where it's starting from. So here will be 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Then here will be 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Why am I using 0.1, 0.4? It is because I realized in the first case we discussed, I said let's pick a number close to 0.5, and we say let us pick 0.4. Because when you pick 0.4, it close to 0.5, it will only make one space to be empty. But if you pick like 0.1 for the vertical one, you see that 0.1, 0.2, 0.3, 0.4, 0.5, it will be starting from 0.5, leaving a big space at the down. So we say start from 0.4. Then for horizontal, we decided to start from 0.1 because if we start from 0.1, it will make a larger space to be covered. But if we start from 0.2, it will stop like middle of the graph, and that will be a wrong scale. That is for this case. That is when origin, start from the origin is specified, and when starting from origin is not specified. Please pick a number that is close to what you have, to the lowest number you have, such that when you now when you take the highest and minus that number you started with and divide with the space you have, you can see what to use to what assign here. Then do also to this aspect. Now we want to see another case. We want to see another scale. Now, assuming you are given the following reading, they say here is H, 1.8, 3.6, 5.4, 7.2, 9.0. For here N, 8, 12, 16, and 20. Now, assuming that this is the reading for H and this is the reading for N, and they say N against what? H against N. H against N. Plot the graph of H against N, starting both sides from the origin. If they say starting both sides from the origin, you know the lowest is 1.8. 1.8. If I put 0, 0 here, that means starting both sides from the origin in a visible way. That is by writing it for them to see it. What I will do is that I will say 9 minus the point I start with. This is for vertical H. The highest minus 0. This is for vertical, that is y-axis. 9 minus 0 is 9. Divided by 9 minus 0 equal to 9. Divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 9, everything will be 1. That means I am going in the interval of 1. 0 plus 1, 1. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. 6 plus 1, 7. 7 plus like that. I will have it this way. Then for the horizontal, because I'm starting from the origin, you now see that if I'm to locate 1.8, 1.8 will be around here. That is, it's still close to the, just a small space is what is left. Then you say it's a good graph. That is why I cannot come and be putting the symbol that will show that we observe the rule of starting from the origin. I will not come and put it because it will only leave a small empty space starting from origin in a visible way. Now, for here, 20 over 0, 20 minus 0 equal to 20 all over 10. That will be giving you 2. That means what I will be having is in the intervals of 2. The answer you get tells you the interval. 0 plus 2, 2. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. 10 plus 2, 12. 14, 16, 18, 20. With this, you have gotten the appropriate scale for this. Recall, I said it has many rules. 1, if they say start from the origin, and the number you see when you start from the origin, when you plot the first one and you see that it is a small space it gives, it is okay that you have to start from origin by writing the origin for them to see it. But like in the first case, where if you start from the origin, you see that a bigger space will be left because of that first case. Don't start from writing 0, 0. Just put a symbol as I said earlier on. That symbol will send a message that you will observe the rule of starting from the origin. And what you now do is you pick the closest number you want to start with, and from there you get your interval by saying the highest minus that closest number or the first number you pick. We pick 0.4, we say the highest minus 0.4 all over the space we have. From there you get your answer. You approximate to see that you get a number you can handle well. So choosing an appropriate scale simply means choose a number you can put here, choose number you can put here, such that it will accommodate your graph, it will accommodate to third of the graph, and you can handle that number very well. Okay, so that is how to choose your appropriate scale. We now go to plotting of this graph. It's important for one to know what we mean by writing your scale. This is a typical example of standard graph. This standard graph is in 2 cm. That is, this bigger box is in 2 cm. 2 cm. 2 cm. So when you match the 2, it becomes 4 cm. When you match 3, it becomes 6 cm. Now we are taking this standard graph to be this graph. If I come now, they didn't specify starting both sides from the origin. Okay, in this graph, plot a graph from this against this. They didn't indicate starting both sides from the origin. See what I will do. It's possible that I will not start from here. You know why? If I start from here, for the vertical axis, here, if I start with 0.4, as I said, 0.5, 0.6, 0.7, 0.8, 0.9, I will still see space, right? Yes. Now, to make it very best for you, what I will do is, I will not start the plotting from the beginning. I will start it around here. I'll put my arrow of the horizontal around here and put, this is my sine what? R. That means for the vertical axis, here will be 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Then for the horizontal, we decided to start from 0.1 before now. We stated this is for horizontal and this is for vertical. Now, what I will now do here, we said the interval will be, since you start from 0.1, we say this minus 0.1 will give you 0.53 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 10, it will give you 0.053. That is, we started with 0.1 and the highest is 0.63. We said 0.63 minus 0.1, that is 0.53, all over. We have 10 boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I am using 10 because I want to use 10. That will be giving me 0.053, approximately 0.1. That means the interval I will have is 0.1. 0.1 plus 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Then 1.0. I want to let you know that, do you know that I can shift this vertical axis inside? Yes. So that there will be no much space left here. I can say, okay, bringing it inside here, I will be having my axis to be here. Here to be sine what? I, no unit. Here to be 0, here to be 0.1, 0.4. Then 0.5, 0.6, 0.7, 0.8, 0.9. Then here to be 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. You now see that small space is left here and small space is left here, meaning that this portion of the graph will be well accommodated. You can have it this way. Now, having it this way, that means we have logics to play here. Once you have noted the interval you are to use while plotting this graph, that is, start from somewhere, take a note of where to start, if it will be from the origin or if you are to pick a particular point, and you say this minus that particular point all over the space you have. That space, that will help you to know the interval you have to use. Now, using that interval, you have to also consider whether there will be space left or whether there will be less space left. If there will be much space left, try to shift your vertical axis in or your horizontal axis in, so that it will balance up. The space left you leave here and the space you will leave here will at least will not be much. Now with this, I can plot this graph. I will plot it 0.5 against 0.3, 0.5 against 0.34, right? So it's about around here. Then I also want to plot 0.6 against 0.4. Okay. I also want to plot 0.64 is around here. Then this is 0.43, right? So there are small lines in your graph. That each one here is 2 cm, each one 2 cm. That small lines are 10. Now you can note the value of each. If you want to know the value of each small line you will be seeing here, what you do is, they are up to 10. What you do is 0.3 minus 0.2. 0.3 minus 0.2, that is 0.1, all over 10, 0.01. It means that each line or each space you see inside here is 0.1. Each space, each small space inside this big box is 0.01. Okay, then that means 0.21, 22, 23, 29 to 0.3. Each of them will be 0.01. Same with this 0.01. Now what you do is 0.6 against 0.4, 0.64 against 0.43. That will be around here. 0.77 against 0.52. That will be around here. 0.87 against 0.59. That will be around here. 0.94 against 0.63. That will be around here. Now, after getting it, you have to take your line of what? Best fit. To take your line of best fit, it has rule. At least the points that will fall out will be on opposite side of your line of best fit. If 2 points are to fall out, they will not fall in one side. It will fall in opposite side. If it is 1, no problem. But if it is up to 2, on opposite side. Okay. Now let's pick our line of best fit. Now we are done with the plotting. You see that it's 1 point that fell out in this from the line of best fit. Only 1 point fell out. So what we do is that we now say, look at our line of best fit, and we are to get our slope. They say calculate the slope. To calculate the slope, you draw a triangle on this line of best fit, such that it will cover at least 2/3 of this what? Graph. So that it will cover 2/3 of this graph sheet. So I can pick it like this. You have to write your scale. Don't forget to write your scale, either on the top or on the down part of the graph sheet. Now scale here, we say each of these big balls is 2 cm. 2 cm represent, for vertical axis, represent 0.1 unit, no unit attached to it, because sin I has no unit. That is for what sin I axis. Then you also say 2cm represent 0.1 unit in sin R. So it is not 0.4 you started with that you have to put represent 0.4 unit. You are representing it with the difference between each 0.7 minus 0.6, 0.1, right? Then it means that it is 0.1. 0.5 minus 0.4, 0.1. That is the difference, the interval. That is what the 2cm is representing. 2cm represents 0.1 unit. That is also the interval for horizontal axis. Now, I've talked about put your date, put your title, label your Cartesian axis, your vertical axis and horizontal axis. Please, we don't call this y-axis, we call it vertical axis. The reason is that this might not be labeled as y. In this case, it's sin I. In this case, it's sin R. So here is not x-axis, but sin R axis, horizontal axis or sin R axis. So put your date, put your title, label your axis, write your scale. Very important. Now we have plotted the graph. You take your rectangle on the line of best fit. You have change in sin I, change in sin R. This is for vertical, this for horizontal. That means when you have something like this, you are taking this to up to 2/3 of the graph, this triangle. Now when you have this will be your y2, the down one y1. Then where the vertical and horizontal meet, you have s2, then here s1. So what we do, the highest here is 0.9, this is 1.0, here highest is 1.0 minus here 0.5 all over here is about 0.65, and where this meet is about 0.32 in estimate. When you minus, here will be 0.5 over 0.33. So when you divide it, 0.5 divided by 0.33, that will be giving you 1.52 approximately. Yes, our slope is 1.52. This slope will be called the refractive index of the rectangular glass prism. Now, do you notice that in the starting part of this video, we use the refractive index to be 1.48. 1.48. Yet, we didn't arrive at 1.48. That is, reason is one, we use a rough sketch of the graph. We didn't use the ray graph. So when you use your ray graph to plot these values, you will get the actual value. Even from here, you see that the answer is 1.48. When you take the average of this, it will give you 1.48. That means when you plot it accordingly on your graph sheet, you will get the actual value to be 1.48. Now, we take 1.52, and this 1.52 still fall in the range of the refractive index, which is 1.46 to 1.54. That is why we can still go with it. Yes, it falls in this range. And that means anytime you are picking any value of refractive index to be used, please pick like 1.46, 1.47, 1.48, so that by the time estimation will be done, the answer will still be in the range. Because if it falls there in that range, it means it still obeys this range. Now, having gotten our slope, we want to get our what? Next answer, estimate the error in the slope. To get the error in the slope, we use the formula error in the slope 4W all over NR, where W is called the vertical scatter. How do we get this W vertical scatter? Look at, there is only one point that fell out. That point, draw a straight line that will pass through that point and it will parallel to your line of best fit. You have seen it now. Look at the point, look at the straight line I drew to be parallel to the line of best fit. Now, as you have gotten into this stage, what you now do is put your ruler vertically. That is to say, if you have 2 points fell out on opposite side of your line of best fit, draw your parallel line, draw another parallel line on this, then put your straight ruler and connect it in a vertical way, in a purely vertical way. You can see it. This, take the value, take the value. Now, if it is only 1 point, just draw only one straight line parallel to the line of best fit. That means when you now put your ruler straight and put a vertical line, look at the vertical line, you trace it to this, then you trace this one also, the lower point of it. After tracing them, here is around 0.65. We are using approximated value, that estimation. That is why we will be getting an answer that is higher. So when you use your graph sheet, follow this same process, you will get it. If you decide to put your line of your vertical scatter this side, you can also do at any point on this line. At any point, you can put your vertical scatter. It's not a more that it is this point. At any point, I can start it here. I can use here and use here. That is 0.9 and 0.85. That is what I subtract. Here, 0.7 minus 0.65. That will be giving me 0.05. That means that my W is 0.05 in approximated value way. 4 times 0.05 all over any means number of values of number of points you plotted 1, 2, 3, 4, 5 times, then arrow mean this minus this, the highest value in the horizontal axis minus this one, that will be giving me 0.29. Now you put this in your calculator. When you put it in your calculator and simplify, you will be getting 0.14 approximately. That means your slope will be 1.52 plus or minus 0.14. That is how to package it. Whatever this gives you, please write it. I just estimate. So whatever it gives you from your calculator, you write it. Then your slope will now be 0.52 plus or minus 0.14. Now they say, what is the intercept of your graph? Intercept on vertical axis. This is your vertical axis. Intercept means where do your line of best fit meet the vertical axis. This is 0.4, 0.5, 0.4, 0.3, 0.2, 0.10. It means it meets it at 0. We say our intercept is 0. Does it obey Snell's law? Yes. The reason being that Snell's law says that refractive index is equal to sine I all over sine R. This is what Snell's law states. That means when you plot the graph of sine I against sine R, what you'll be getting is a very straight line, yes, which will have a positive slope, called the refractive index, and also it will pass through the vertical axis at point 0. Yes, that means in Snell's law, the intercept on the vertical axis is always 0. So when this pass through 0, it means it obeys Snell's law. 1. When you have a straight line with positive slope called the refractive index, it also obeys Snell's law. Okay, so we can comfortably say that it obeys Snell's law.